Good afternoon, ladies and gentlemen. So I'm here today to talk to you about organic semiconductors. Now, organic semiconductors are really taking the world by storm when it comes to new materials and new types of electronics. So let me give you some reasons for this, why this is so interesting. We have a very, very rich and tunable chemistry. Right, there's a lot of things that we can do in terms of customizing materials for specific applications. Now, an example of that are the things that look like colored windows on the right-hand side there, the center right. They look like windows, they're actually solar cells. So these are power-generating systems that we can make. We can adjust the color, we can tune this and install these in buildings in an artistically beautiful way and generate now electrical functionality into our architectural designs. We also have another strong advantage in solution processing. What this means is roll-to-roll manufacturing. That's printing. That's how we make newspapers. We make newspapers so cheaply, we just give them away. Now, what if we could do that for solar cells? With this technology, we can. We also have the opportunity to make flexible and transparent electronics. So the example that you see at the bottom left here, these are solar cells again. They've been printed into the shape of a leaf. So again, we're making things which are visually appealing as well as being electrically functional. So what is the problem here? Well, the problem is the difficulties in characterizing these devices are really slowing down the progress in this field. The electrical behavior is more complicated than the conventional electronics that we've been using for many decades. And so this is slowing down our search for new and improved materials. So this is where our research comes in. So what we're doing is developing new experimental techniques so we can understand the behavior of these devices. We can understand the microscopic properties, what's really happening, what are the limitations, why are these things not performing as well as they potentially could. So for example, in a solar cell, one of the big limitations is a process of recombination. So recombination is shown in this artist's impression at the bottom right here. That's a positive and a negative charge coming together, giving off their energy as heat. Right, as wasted heat and not as useful power. So the question is, can we understand that process in more detail? If we can understand it, can we control it? Can we use that then to produce a better solar cell, a more efficient solar cell, and take advantage of the promise of this technology, but do so with something which will be commercially viable and successful? With this knowledge, we are then designing new device structures, taking advantage of what we have learned and really trying to push forward this field, basically with organic electronics take over the world. Thank you.